Hello guys, welcome to Deep Codes, and in today's video we will discuss LeetCode question 104, that says maximum depth of binary tree. So yeah, here we are given one root of a binary tree and we need to find the maximum depth based on the root. Okay, and further the depth of a depth is defined as the number of nodes along the longest path from root to the farthest leaf node. Means let's say this is the root node, correct? Then the number of nodes along the path to the farthest leaf node. So the most distance leaf node is this 15 and this 7. So how many nodes are there along the path? 1, 2 and 3. And here also the same 1, 2 and 3. So yeah, we written 3 as our depth. That is the depth of our binary tree. So yeah, that's all for the question part. This is also, let's say, 1 null, that means left child is null and right child is 2. So 1 and 2. So there are 2 nodes to the farthest node. So yeah, we written 2 as our answer. That's the depth of the binary tree. Okay, and also one thing to keep in mind, that since this is a binary tree, so at max a child can have only 2 children, right? And talking about the constants now, the total number of nodes can be 10 to the power 4, and each will contain value from -100 to +100. So yeah, as you guys know that this is a tree problem, simple tree problem. So there are two ways to solve this question. First is DFS and second is BFS. The intuition is simple, right? We need to just traverse all the node and we need to find the depth. So yeah, now let's us try to determine how the DFS works. Okay, so here in this approach we will check that, we will learn that how the DFS approach works. So in a DFS approach we start from a root node to up till its all its child node. Okay, so let me make one node here, let's say 6, let's say 7 here. Okay, so let's say this is a given tree, correct? Now we have one root node, so assume that this is the root node. Okay, the node 0 is a root node. Now how DFS works, the depth first search. So in the depth first search DFS, what we do, we travel from a root node to the child node, then again the child to its child. So this way we would travel from this root to this child, this root, this to this, this to this to what is that? Null. So if there is, if it is null, we would stop, and we would go back. So this is backward traversal, like we would return. Okay, then we came here, then this child is remaining to travel. Okay, then we would travel this child, then again we would go back. From here we would go back, from here we would go back. So this is how DFS traversal works, like here from here. Now this child is remaining to travel, so we go from here to here, then here to here. Okay, now that is null. Now it is null, so we again go back to parent. So this child is remaining to travel, so we travel this. Now further it is null, so we again go back to parent. Now we again go back to parent. Yeah, so this is how DFS traversal will work. We move to child and we again go back, correct? Now in DFS traversal, in order to calculate the depth, what we need to do, we need to calculate depth. See, in order to calculate depth, what we need to return, we need to return something, correct? Yeah, here we are returning to the parent, so from child to parent we need to return something. Okay, so what you will return, we will simply return the depth of each tree. So assume that this is 7, there is only one node. So let's say there is only one node, let's say this node. So what is the depth of this tree? The depth is 1, correct? For a node only one node, the depth of the node or the depth of this tree can be said as 1, correct? So what this 7 should return? See, beyond 7 nothing is there, null. So here, since this is null, so our base condition would be 0, return 0. If null, then return 0. Else what we will do, as we will return 1. Okay, here from here also we would return 1, here also we would return 1. So at each node what we will take, maximum of left comma right, left answer comma right answer. So here maximum of left and right is what? 1. Means 1 is only the maximum of both. And what this 3 will return to? It will return 1 plus previous answer. Simple, 1 plus previous answer. So it will return what? 2 here, 1 for itself and 1 for this child answer. Okay, so what now 1 will return? It will return 1 plus previous answer. Simple. So what that is, it is 1 plus 2, that is 3. So 3 would be returned to here. Now 0 is also one node. So what would be total answer? 1 plus previous answer. So here it would be 4. Now do this had to be written to anywhere? No, 4 is stored here. Okay, correct? Now again we move to right hand side. So on right hand side, here what this 4 will return, this will return 1, this will return 1. Similarly this 2 will take maximum both 1 and 1 and add 1 to it, so it will return 2. And here it 2 will be passed to 0. Now 0 has to compare either 4 or 3. How 3? This 2 plus 1 itself, so it's 3. So it will compare 4 or 3. What is the maximum? Maximum is 4. return 4 as our answer. Simple as it is. I hope you guys understood this DFS for it. This is simple, like from a parent child we are calling to child, then its child, then its child, until we get to null, then we start returning. If it is null, then we return 0. This is a base condition, and we return 1 by 1. See, if there is only one node, then the depth is 1. So yeah, for each node the depth is 1 itself, and plus the depth of child. So 1 plus 0 is 1, so we return 1 here. Here also same thing, 1 plus previous answer or the answer from the child. Here also 1 plus answer from the child. The same thing goes on here, and this is how the DFS function works. So we are now talking about the code for this DFS function is. So yeah, this is the code for DFS function. Like this is simple, like as we saw that here, let's say 0, 2, we are moving to 1, let's say 2, and let's say here we are going to 3. So yeah, what we are doing, we are starting from root is 0, right? This is root. So from root we are traversing to left child and right child. Okay, now left child, let's say the left child is there. The left child, we are recursively calling this solve function. So here it is null, so this condition is hit when the parent is 1, its child is, there is no child. So what we are doing, we are simply returning 0. Okay, 0 is returned. Now what does this would be for root of left, means 0's left 1, this what would this return? This would return 1. Okay, means 1 will also return 1 for itself here, correct? So yeah, that is one thing. Now another thing is what we are also calling the right hand side. So yeah, 0 to 2, then we are calling the function recursively. So this 2 will call to its children, right? 3, correct? Okay, now 3 will call to its children, that is null. So what null will return? Null will return 0, as you see. Now 3 will return? 3 will return 1 for itself, because its left and right child both are null, both are 0, so 1 for itself. Okay, and what this 2 will return? 1 plus the previous answer, that is 2. Okay, correct? So yeah, so what would be here? It would be maximum of 2 comma 3. Okay, this what would be the last maximum 2 comma 3, that is 3. So we return 3. Our answer is for this tree, correct? Simple as that. So I hope you guys understood the DFS approach. So that's all for the approach as well as coding part for DFS, but still we can solve this question by BFS also. Okay, so now let's move on to the BFS approach, that is breadth first search approach. So guys, as you know, in breadth first search approach, what we do, we traverse the tree by level wise. Okay, so let me make this tree more dense. So 6, so this is 7, let's say here it is 8. So we travel the tree level wise. How level wise travels occur? See, this is the first level. So at a level our answer is 1, we increment our answer to 1. This second level is possible, yeah, then plus our answer becomes 2. This is third level, our answer becomes 3. This is fourth level, right? Our answer becomes 4. And this is fifth level, and our answer becomes 5. Any other possible levels are there? No, everything is null here, nothing is there, so we stop. So 5 is our answer for this question, right? For this tree, 5 is our answer. Yes, there are 5 different levels that we can traverse. But how we will solve this? How we will traverse different levels? So if you might know that if you might know that BFS traversal, we use something known as queue data structure. Okay, and each point for each root we would push its children to the queue, like children are pushed to the queue. Okay, and yeah, and what we would do level wise traversal. So at a time all the children that are present in the queue are traversed, correct? So yeah, that's how this BFS traversal will work. Now let's also see the code for BFS traversal, and let me try to explain you with one example again. 0, 1, 2, 3, 4, 5, 6 and 7. Okay, like keep it's this tree. So initially, so this is the base condition. If root is if not root means root is null, then return 0. Okay, then when we took one queue and we initialize one depth variable to 0, we push root to the queue, correct? Now here this BFS function will be called. So as you know that BFS function will work until the queue is empty. So yeah, this, and every time we make a BFS call, we will increase the depth because we are traversing level wise, correct? Now yeah, here what we are doing, for how many elements, for all the elements present in the queue, we will traverse its left and right. So yeah, initially for 0 is present, we will travel to 1, 2, node 1, 2, correct? Its left root and the right node. Okay, and yeah, we will increment our answer to 1. Currently it's 1 here for this stream. Now again we are traversing, right? Now what, this is q, this is its children, and this is the answer. So in the, now the queue will have what, 1 comma 2, as these children are pushed to the queue. You can see here we are pushing the children. So 1 comma 2 will have what are the children of 1 and 2? The children are 3, 4, 5 and 6. These are the other children, and currently our answer becomes 2. Okay, so now 3, 4, 5, 6 is in our what, queue. This all we are pushing children to the queue. So now 3, 4, 5, 6 is in our queue. What are the children of 3, 4, 5, 6? Only one, 7. So yeah, our current answer is 7. Now what does queue have? Queue have 7. Okay, this only 7 remaining in the queue. What are the children of the 7? Null. So here queue, so here our answer becomes 4, and next time for iteration queue is null. That means queue is empty, and whenever queue is empty we stop, right? This condition breaks and this condition breaks, then we return answer, that is 4. As simple as this. Level 1, level 2, level 3 and level 4. Simple as it is. So yeah, this is how BFS traversal build works. So I hope you guys understood the BFS traversal approach as well as coding part. Now talking about the time and space complexity, the time complexity of both the DFS traversal and the BFS traversal would be big of n, as we are traversing all n nodes. So yeah, time complexity would be big of n, and also the space complexity would be big of n, as we are storing the nodes, correct? Here the nodes are stored in the queue, and in DFS that would be one stack, recursive stack, because we are doing a recursion, so the recursive stack will store the nodes. So yeah, the space complexity of both the approach would be the same, that would be big of n. So yeah, that's all for this video. But apart from this, what I would suggest you this, see, this is a simple question, because here you have binary. Now if you have understood this question, then do try to solve this question. Which question? Maximum depth of an array tree. Okay, this question is the same as the binary tree, but the only difference is there can be more than 2 children. See, here in the binary tree, what we are checking in the DFS call, we are checking for only 2 children, that is the left child and the right child. But the only difference here would be that instead of 2 left and right, there can be multiple children for this n array tree. So yeah, I make sure you check this question out, and if you have any doubts in this question, make sure you check the video for this question on our channel. Okay, the link would be for the link for this video would be in the description. Okay, so yeah, that's all for this video. And if you have still any doubts, then do let me know in the comment section. Make sure you like this video and subscribe to our channel. Thank you.